So let's see. I'm looking at this is question 2 in the assignment in PChem. So first off, what we're talking about here is they want to know what the change in the slope of chemical potential versus temperature would be going from solid to liquid, for instance, or from liquid to solid. Now, we already seen earlier that the slope of the graph of chemical potential versus temperature, they're negative slopes. And the reason for that is this. So the slope of this graph is always a negative of entropy, right? The entropy of the thing you're looking at. So for instance, the entropy of a solid, liquid, or anything above absolute zero is automatically a positive number. But this relation is telling us we're taking the negative of that. So in other words, this slope is always negative, and so is the liquid one. But the magnitude of entropy of a liquid is larger than that of a solid. So when you go from a solid to a liquid, the slope of it has to get steeper in that way. So let's just go over one thing real quick, and it's because it's confusing with the negatives. So if we go back to math class here, so let's just pretend that's an S, and that's an L for liquid. If I just randomly assign a -2 to this slope, when you switch to this one, it obviously has to be a bigger number, so I chose -4. So think of it this way. If we were to traverse this from solid to liquid, then the change in the slope of this graph would be final, which would be that of the liquid, which is -4. Subtract off that of the initial, which was a slope of -2. So the change in slopes, if you're going from solid to liquid, would be -2 joules per K per mole. Right? What's interesting to note is this is the change in the slopes of this graph, which is equal to the negative of actual entropies. So it turns out that this change in mu, this change in delta mu over delta T at P, the change in those slopes, is a negative quantity. Whereas the change in entropy at that exact same one traversing it would be opposite that sign. It's tricky. If we redid this calculation with, what if we went from liquid freezing to solid? So the final would be the liquid. Hold on. Liquid to solid, the final would be the solid, which is a -2, subtract the -4 of the initial, which was the liquid. So you're getting a positive change in slope in that direction. But this is the change in slopes, which is chemical potential over T, which is the negative of what change in entropy would do. So I think what I'm looking for here is, and I'll walk you through it, because the book, I think, has a little miscommunication on the signs here. So we'll walk through. If we're saying the normal freezing, then the way it is you're going from liquid to solid. You're freezing it. We know that this is the opposite of fusion. The book gives us a positive value for the fusion, which is the melting. So technically, the delta H of freezing liquid to solid would be a negative joules per mole. So that's the delta H. We also know, I'll hide that, over here, we want the final minus initial. So if our final thing is heading from liquid towards solid. So what is the slope of the graph of the solid side? Subtract off the slope of what the liquid would be. So the slope of the final one would be the negative entropy of the solid. Subtract off the initial, which is the negative entropy of the, that was the solid, this is the liquid. So I could factor out a negative for both terms, and I would get the entropy of the solid, subtract off the entropy of the liquid. So this right here would literally be the change in entropy when you freeze water. The negative has to stay way out front because of this fact. So all we have to do to calculate this, which is the change in slopes, you would get the delta S, which would be, what is the delta S of freezing? So this says you take the delta H of the transition divided by the temperature of the transition. Well, the delta H of freezing we had up here was a negative, right? And we have the other negative in front, so I get a positive answer. This is what happens to the change in the slopes of that graph. And it matches exactly what we were saying, which was final was a solid, just like we did down here. If the solid, that's your initial liquid. So the slope of the solid is a smaller negative number than the initial liquid, which is a bigger negative number. So when you go from liquid to solid, the changes in slopes has to be a positive quantity. This is not actual entropy. You'd have to flip the sign because the entropy is doing the opposite of that. So the answer to this question should be, technically, by the wording, if we are saying, let's go from liquid freezing into solid. If that's the case, then our answer has to be the negative of what the change in entropy would have been, right? When you take liquid and you freeze it, you would get a decrease in entropy. But we get a positive in this case because we have to have the negative in front. So long story short, I mean, it's a bit confusing to put this all together, but that's essentially how assignment number 1, question 2 would work out.